What if the most important measure of aging isn't how long we live, but how well we function? What if aging is less about individual diseases and more about declining physiological reserve, muscle strength, mobility, metabolic health, and resilience? Today's guest has spent decades studying aging not in theory, but in real populations, long term clinical trials, and functional outcomes that directly shape independence and quality of life. Welcome back to Decoding Longevity. I'm your host, Raghav Sehgal, here with my co host, Macsue Jacques.
Hi, everyone. In our last episode, we have explored metabolism and immune aging. Today, we are focusing on physical function, body composition, and the clinical translation of Geroscience. Our guest is Dr. Steve Kritchevsky, professor at Wake University, Forest University School of Medicine, and a leading investigator in aging, metabolism, mobility, and sarcopenia. His work has shaped major studies such as Look Ahead, and other landmark trials examining how lifestyle, weight loss, and metabolic health influences long-term functional outcomes. Steve, welcome to the podcast.
Thank you. Thank you for inviting me.
Steve, it's so amazing to have you here. You have been sort of a tour de force in the field, I would say. Your career has, you've spent it sort of studying aging through so many sort of functional measures, walking speed, strength, body composition, metabolic health. You've spent sort of so many years sort of looking across sort of tons of data.
Yeah.
What do you see as the central biological shift that defines aging?
Well, I guess I would not necessarily call it a central shift. We see progressive and then accelerating changes that occur with age. And it depends what you're looking at. If you're looking at bone, you have the most bone you're ever going to have in your early 20s. If you're talking about muscle mass, that peaks in the 40s. And after those, the capacity, the reserve starts to decrease. And unfortunately, unless we do something about it, those decreases continue until there's some kind of catastrophic failure, a fall or a broken bone, a stroke, other disease may overtake you. So it's not so much. I don't believe that there's a different biology when we're young than when we're old. It's the same biology. It just sort of plays out over a life course.
Yes, no, that is very interesting, and I am totally, for the muscle strength and building up muscle as much as possible. So later on in life we can maintain this.
Right.
So this is one of the themes of your work is also mobility. That is just not an outcome, but is it also could be used as a powerful biomarker. So measures such as like gait speed, strength, in aerobic capacity, like as VO2 max, they can predict hospitalization, sometimes even mortality, disability, and so on and so forth. So why in your eyes or in your lens, do you think mobility captures aging so effectively?
Yeah, well, first the empirically, when we see what happens to people as they age, we see disability occurring as a progressive process. It doesn't usually happen all at once. It can. You can have some catastrophe in your health, but typically it doesn't. And the very first thing you see in that trajectory of decline are impairments in the ability to walk, and especially walking moderate distances. And you're right. If we compare people who are walking quickly to people who are walking slowly, the people who walk quickly preserve cognitive and physical function better, much less likely to become disabled, get fewer diseases over the next several years, and are much less likely to die. And a motivating question in a lot of my research is, why should that one thing be so powerful and predict so many different kinds of things that don't ordinarily seem related? And I think it's because it integrates a lot of physiology and biochemistry are all integrated into mobility. So you need an intact nervous system, your brain has to be working well, your muscles have to be working well, your heart has to be working good enough, your joints all of these things contribute to what speed you walk. And there's something in it that captures how well your physiology is integrated, which gives you a readout on how everything's working together. And a lot of aging is really not that the pieces work, but they're kind of coming apart. They're not working together as well. And we see that in a lot of ways at every level of biologic organization. As people age, things start to unravel somehow. So that's why I think it is. It just is the sum of the parts. It's like looking at a great picture, a great masterwork of a painting. You don't look at only the blue color or the yellow color. You see how it all comes together. And when that picture starts to smear, you know something is wrong.
And now you have also sort of tried to modify these trajectories and
Right.
conventional work. Well, one really great example is the Look Ahead trial, which was originally designed to test intensive lifestyle interventions in individuals with type 2 diabetes. Now, of course, if we view it from a geroscience lens, what has the study really taught us from an aging trajectories perspective, beyond if you think about glycemic control, right?
Right.
What about long-term function and cognition?
Yeah, so the Look Ahead trial started a long time ago, before I got involved with it. And it was to test the hypothesis that an intensive lifestyle intervention, which focused on more exercise and weight loss primarily, would slow the rate of cardiovascular disease in people with type 2 diabetes compared to an education control group, a support group kind of thing. Big study, over 5,000 people were randomized, 18 sites across the United States. I got involved when I thought, we'd really like to know about aging outcomes, because this is a really important intervention, because the animal literature is all telling us that these things should improve lifespan and health span. And this is one of the few opportunities that had enough people who are being followed for long enough to even have a chance of answering that question. So we added measures of mobility, gait, walking speed and walking endurance, and cognition. And we also brought into the study some geroscience or gerontologic concepts like multimorbidity. So the accumulation of extra diseases. Also, this idea of frailty by accumulation of deficits. So there is a version of frailty that's used in aging research, which is you could have 50 age-related things wrong with you. How many do you have? What percentage of that 50 do you have? So my colleague Mark Esplin and I and many others looked at the impact of this intervention on people with type 2 diabetes, both in terms of the number of new diseases that they would accrue, and also the number of health deficits that would accumulate over now 15 years of follow-up. And both, there was a small but measurable benefit, such that it appears that intervention may have delayed aging a year in the people randomized. So the rate of accumulation of health problems in the intervention group was delayed about a year compared to the control group or the non-intervention group. And that benefit has persisted for over a decade. So that's very encouraging. That gives some hope that there's some aspects of the aging process that are in humans. We know in animals for sure it is, that in humans that curve can be bent a little bit.
That is really cool study. I am wondering, because obviously we talk a lot about getting, losing weight, and there is a persistent clinical debate that weight loss in older adults can be very beneficial for your metabolic health. But at the same time, we really worry that unintended or this loss of weight or of pounds can be actually due to muscle mass loss. And sometimes when you're actually losing weight, you're actually also losing a lot of muscle mass, which can be very detrimental. So your work on long-term body composition provides a lot of clarity in this area. So how can clinicians balance fat loss to improve metabolism while preserving muscle mass, which is the ultimate goal to maintaining this physical function?
Yeah, I know that's the question that our center has taken on for the last 15 years. Uh, and it was motivated. I saw a geriatrician at a national meeting who said if a geriatrician asks an obese older adult to lose weight, that's malpractice.
Mm.
And I thought that was crazy because in all our epidemiologic research, we find that the amount of adiposity has a much bigger impact on function than the amount of lean mass. And so something wasn't connecting. So we've done a lot of mostly short-term, but some long-term work as well, or as long as we can do it, to see what on balance is it a good idea or a bad idea for an obese or overweight older adult to lose weight. So if they're already thin, we're not suggesting that. But if they have an indication for weight loss at 50, do the same rules apply at 70 or 75?
Mm.
And all what you said is exactly correct. We see metabolic benefits. We see decreases in feeling perceptions of fatigue. We see a strong decrease in inflammatory and age-related biomarkers associated with those interventions. Glucose goes down, all the things that you'd want. But when you lose weight, you cannot lose just fat, or we don't know how to engineer weight loss, so you only lose fat. You lose lean, you lose muscle, and you lose bone. Here's a curious fact that we found. So we do imaging on all the people in our studies, and we see that their muscles get a little bit smaller after weight loss. But when we test the function, either through gait or through measuring muscle strength, people don't get weaker and they walk a little faster.
Interesting.
So at least in the short term, I think I'm not this idea of muscle quality, which is how much bang for the buck do you get? So for a given amount of muscle, how much strength you have seems to improve with the weight loss.
Yeah.
Now, the loss of bone probably will put people at some point at somewhat increased risk of fracture, because that's bone density is a very important predictor of whether you're going to fracture after a fall or not. And I think the question for the field right now is, on balance, which wins? Is it the functional benefits and the reduction in the introduction of new diseases? From the look at experience, is that on balance better for you than a hypothetical increase in in muscle strength loss, which we don't see on the short term, but it might be true over a longer time, or a somewhat increased risk of fracture? We're putting in a proposal for a 1,400 person randomized trial, we hope in September, which will actually is addressing exactly that question. And if we get to do it 8 years from now, I'll have an answer for you. It takes a while. It's a long-term study, but we're very excited to be planning it. If you talk to geriatricians, the reason that there is a controversy at all on this is that when an older person presents to or shows up at the doctor's office and they've lost weight and they didn't try to lose weight, there are bad things in the future for that person. And so I think that is a very vivid clinical sign of something going very wrong. And it really affects people's overall judgment of whether or not weight loss is good or bad, because if people are losing weight and they don't mean to, it's bad. There's no doubt about it.
Yeah. So perceptionally also, like so often when we say someone's frail in their old age, how often perceptionally it's saying someone's weak, like they look thinner, they look weaker, right? And that weak perception often comes from the fact that they have lost some weight. as they have gained
Yeah.
age.
Yeah.
Uh,
Yeah. They lose
uh,
weight, they slow down, they get weaker,
yeah,
they
yeah,
have little energy. Yeah. All those things. Yeah.
yeah.
That's right.
It's very well put. And I guess one question is, and I want to have a follow up before I ask my next question to you.
Hmm.
So this study that you're mentioning, this sounds like a really exciting study that you're
Hmm.
planning. Is this a follow up to sort of some of the exercise interventions that you had planned, or is this a new study where you're trying sort of a new intervention? Are these GLP-1s? How are you thinking about this
Right.
study?
The study we're planning is based on a sort of interest of the National Institute on Aging in this topic. It's really a follow up of a study they did, started about 15 years ago, or maybe even more than that, 20 years ago, called the Calorie Trial,
Mm,
where they did behavioral weight loss
yeah,
in younger people who were not overweight or obese to see if it was feasible and look at biomarkers to see if there's any evidence that the patterns of change or the effect of it that they would see in humans that all mirrored the animal literature on caloric restriction.
yeah,
And it seems to some, actually, it does. And so National Institute of Aging wanted to, and we are right on board with that because we think it is the right question to ask, wanted to do this in a longer term period in older adults and younger adults. So
yeah,
there's another center working on a younger adults study. We're working on the older adults study. And in the older adults, we are using behavioral weight loss as the major. So, counselors and guidance and group process to get people to lose weight
yeah,
and reduce the amount of intake. We're keeping our eye on the GLP-1 story very closely because there's no doubt that you can get sustained caloric restriction pretty reliably with them. With those classes of drugs, you hear rumor, I guess rumors and some data that people don't like to stay on. People don't want to stay on them forever and don't even, and there's a lot of people who do them for a while and then drop off.
yeah,
Also, they're all under patent and they're extremely expensive. And, if we actually use one of those drugs, it would be almost the biggest expense of the whole study would be just the cost for the drug. So that's slight exaggeration, but not that much exaggeration. So it's just not feasible. And I think there's a public health issue here that these drugs are not available to everybody. And we want to test something that everyone could do.
yeah. That, that's a very, very, very valid point.
Yeah.
All actually. I do want to follow up, do want to sort of ask my next set of questions to you. So, of course, your work has, of course, extended in this direction into sarcopenia, right? And sort of advancing our understanding of sarcopenia, particularly sort of the distinction between sort of what is muscle mass and muscle quality, which you were just talking about.
Right.
So how sort of do you sort of distinguish between what is sort of muscle quality sort of emerging as this more meaningful predictor of function, right? Why is it so critical, and why is it sort of more important to look at it as compared to sort of muscle mass only?
Right. Well, so a brief history of sarcopenia. I was in the world and working when the term was first coined, and the logic went this way. We know people become physically disabled or much more likely to as they get older. A very important part of that is the loss of strength. And what is strength but muscle? And so therefore we should try to preserve muscle. And that all makes sense. But in work that colleagues led in the Health ABC study, we found that when we looked at people's change of strength and muscle through time,
Mm-hmm.
their strength fell much faster than their muscle,
Mm-hmm.
then their muscles declined. And there's also very little correlation between the change in muscle mass that we were able to image with CT and the change in strength. So the correlation through time was about or 0.15, very weak. So that suggests that muscle mass that isn't, I mean, to some extent, if you don't have a muscle, you have no strength. But within the range where people are in the community, it seems to not be the whole answer there. And so we've always been much more interested in muscle function, the ability of muscles to generate power, which is more something slightly beyond strength, muscle strength, more than mass. Because if people have enough muscles to do whatever they want to do and retain independence, that's what we want for them too. And if it means growing their muscles, then that's great. Well, we're interested in that. We've been part of industry trials of interventions that have some effect doing that. To date, those interventions have been a little bit disappointing in how much function people get as a consequence of more muscle mass that we were able to observe through imaging, MRI or CT or something like that. So if we really want to focus on what people want, and what we want as we age is enough of the capacity to interact in an acceptable way with our environment, right? So, and that depends on strength, not mass. So ultimately it does mass. If you have no muscles, you need a head to have a headache. You need muscles to have any kind of mobility. But again, within the range where we see most people in the community, that at least people participate in our studies, the things that are slowing them down are not obvious muscle mass. Exercise trials where people, we have them do resistance training. And if they're very weak, it helps them a lot. It's really important. But if they're not already very weak, it speeds people up about 0.03 meters per second, which is about 3% increase. Most people in our studies walk about 1 to 1.2 meters per second. So it has a measurable effect. It's not a huge effect.
Yeah, very interesting. So another area of your work is exploring the relationship between the neurological or neurointegrity and the physical performance.
Right.
Is there any growing evidence that physical and cognitive aging share common biological pathways? And are we beginning to understand aging as this truly integrated systems level process, or do you think we're still slicing it down based on different phenotypes?
Right. Well, I mean, the history of everything are people working on particular organs. All of medicine in the United States, anyway, is handed out according to anatomy. So there's the neurology and the cardiology and the nephrology. There are some things like geriatrics that try to pull that all together. Internal medicine tries to pull that all together. But there's no question that physical function and cognitive function share a lot together. And one of the reasons I got interested in the brain was my disappointment in how far we could improve people with exercise. It does improve, and it does prevent disability, physical disability, without question. It's definitely valuable. But I've always felt like, boy, could we do some more? Could we do something else? And I realized, that we're not really paying that much attention to what's going on up here and what roles play. So I don't want to bore you with a long recitation of facts, but all the things that are associated with brain aging. So cortical shrinking, accumulation of white matter lesions, which are amyloid deposition, which is part of the Alzheimer's process. All of that is also associated with poor physical function. What's interesting is the problems with physical function seem to precede the problems with cognitive function by a fair length of time. So that brings up a couple of things. One is, we're in a new era in the drug world where we now have compounds that we can offer people, drugs we can offer people early in the Alzheimer's journey or the beta amyloid journey. And so there's not suddenly, but a lot of interest in being able to screen people early in their trajectories to see who might be able to be put on these treatments, and they probably work better early in the natural history than late. And so now we're really interested in what can we observe in people's movement might indicate that they would be good people to include. We just did a cross-sectional study, just a couple within the last 18 months or so, where we looked at all these blood biomarkers that are important in Alzheimer's disease and looked at them for physical function in cognitively normal people, and found that they were associated with physical function in people whose brains were normal, but who tested normally. And so there's no doubt that it should not be controversial to say that people are an integrated physiologic system and the brain is integrated, but somehow it always comes off that way, that you're like, but I think the world is kind of realizing that's not true anymore. So there's all kinds of stuff in the brain that's really important to physical activity, and it's also physical function, and it's the same kinds of things that in a few years later will be important in who declines cognitively. So.
Yeah. Actually, a follow-up question there for you, Steve, which is the delay that we see, right, with cognitive decline as opposed to with physical function, right? Physical function decline typically precedes cognitive decline. Could that also be a function of that, how important cognitive function is for from an evolutionary perspective, right? Like, one can still be less mobile and still survive versus cognitively, if you're not functioning properly, that's evolutionary a lot more challenging, one could argue, right?
I don't know. I mean, I think you don't have to be that smart to know to run from the lion that's chasing you.
That is true. That is absolutely true.
So if you can't run that fast, I think we know who's going to make it to. Well, I think evolutionary arguments in aging, you have to be very careful with.
Yeah.
Because everything we're observing in people in their 70s are well past the age of reproduction.
Yes.
So there's no selection pressure either way. And so I do think that as the systems that support mobility decline with age, people tend to do it less. And I think the muscular part and the deconditioning can happen at a much faster, because you're always using your brain for something all the time.
I see what you're saying.
And so there could be aspects of it, like you can't quite put your finger on it, but today I just don't feel like going to the store, I'm going to do a couple of fewer laps, or so there could be subtle interoceptive things that people are feeling that are a consequence. And if you were an exerciser and you stop, I mean, you decondition very quickly.
Yeah.
In a week, some. And so, I don't think we have a completely acceptable conceptual framework on any of this, but that's sort of how I think of
what I'm hearing is that this is maybe a function of maybe sedentary lifestyle, almost potentially, because sedentary lifestyle could contribute, because I recall there was this paper also which came out about, and this is maybe a bit of a tangent, how sort of industrialized societies see more chronic inflammation as opposed to sort of non-industrial sort of cohorts, where they looked at sort of cohorts in sort of Amazonian populations as opposed to sort of industrialized populations, and they saw that there was significantly more chronic inflammation. So chronic inflammation was a function of somehow industrialized societies. And I'm wondering if sort of some of this, the function is that maybe if you're living in a sedentary lifestyle, we are more function to working on our computer, which is a more mental capacity thing, as you're pointing out, but it's not as much a physical capacity thing. You're not exercising. Maybe you're exercising your fingers a little bit.
I wonder as well, like just to pick back on that question,
Yeah,
there is a lot of new, say, development in drugs trying to do exercise mimetics where,
Right.
you're not losing the muscle, but
yeah,
Right.
what does that mean for your actual functional capacity? Because you might not lose the muscle, but this muscle might not be really optimal. It might not actually be
I,
decreasing the inflammation, might not be doing all of the other functions that exercise
yeah.
itself would do. And I'm very interested to hear what are your thoughts on those new potential mimetics drugs.
Right. Okay. So let me try to queue up in my head my response.
Not too many questions.
Right.
It's so
The
exciting to work,
first
Steve.
thing I would say is, industrial societies, the life expectancy is close to 80.
Yeah,
In Amazonia, it's 40.
yeah, yeah.
So, okay. But everyone can have their pet theories about everything. The thing that I point to as being quite concerning in certainly in the United States is that the typical pattern for an adult in the United States is to gain about a pound a year their whole life. And the way I think of it is your foot is on your metabolic accelerator all the time. And with no relief. I mean, people are putting stuff in their mouth constantly. And you just look at the obesity epidemics, especially in the United States, that we're seeing, and it's pretty clear that that's happening. And I think like the GLP-1 drugs or behavioral weight loss take the foot off the accelerator. And one of the signs of acceleration is inflammation. And we see that if you stop that, even for a little while, inflammation levels can drop. I'm not saying that's the only thing, but that's something that I see. So that is on that and so I think we can lead lifestyles in an industrial society that we can avoid some of those things, and it will be somewhat helpful.
I was just wondering because we're talking about, muscle quality
Yeah.
and,
Oh,
physical
yes.
performance.
Yeah.
Yes.
Yes.
How do you see those
Right.
exercise mimetics
Right.
drugs
Right. Right.
affecting muscle?
Right. So I'm going to tie this back to something I said earlier. One of the biomarkers that's pretty clear is sort of a generalized marker of axonal degeneration is something called neurofilament light chain, NFL. And this is seen to be associated with cognitive impairment and in that process. But we also see it associated with physical activity. Physical function. And the reason I bring that up is you got axons going, neurons going through your whole body. And it's not only the ones in your brain that might be degrading. The thing that I think people miss with giving drugs to grow muscles is the muscles also have to be innervated. If they're not innervated, then it doesn't matter how big they are. They're not going to do anything. And I don't know personally, and maybe others have hypotheses on how to promote the reinnervation of the new muscle that you're trying to grow. Because we see as people age, there's something called axonal dropout, where there are motor connections from the brain all the way into the muscle bodies through the spine, and they drop out as you get older. And there's a consolidation where the same fewer neurons are innervating a bigger bunch of muscles. You lose fast twitch muscles faster than you lose the slow twitch muscles. I don't think it's realistic to think you'll gain a lot of function if you sat strapped to a chair and took one of these pills and could bulk out. I don't think it'll do anything, because I think you need some trophic stimulus in order to direct the nervous system to engage with the muscle.
Those are very, very cool insights. But I'm going to start wrapping this up now, Steve. So I have one big arching question for you.
Okay.
Now, looking ahead 10 years, what are you most excited about in the aging field? Are we sort of moving towards better integration of functional and metabolic biomarkers? Is it
Right.
sort of a precise identification of a frailty risk factor in clinic? Is it sort of clinical trials? What is the one thing that is getting you most excited right now?
Well, something we actually I dabble in. We didn't talk about too much, which is geroscience.
Mhm.
Which is this idea that there's a lot of aging is secondary to some fundamental cellular biology, and we know from animal models that you can intervene on that biology and extend lifespan and health span. And I've been very interested in trying to figure out how you would answer this question. Pill, if I had a pill that could slow aging,
Mm.
how would I know?
Yeah.
How would you know? And how could you get other people to agree with you? So those are actually two separate questions. The first question, a lot of people are very happy with their biomarkers and they think, biomarkers will answer it all. But they won't convince anyone else. They certainly won't convince the FDA because they won't accept biochemical diagnoses of things. So I'm excited about how that field is unfolding
Yeah.
and how we will start to put together things that happen with aging in syndromic ways rather than disease-based ways. So
Yeah.
right now, our paradigm right now is LDL cholesterol leads to foam cells in in your arteries. They cause inflammation there. They burst. You get a heart attack. You die.
Yeah.
And so we want to prevent that by lowering LDL. So that's one target, one disease, one drug. If we slow aging, we'll slow atherosclerosis maybe a little bit. We'll slow Alzheimer's a little bit. We'll slow a lot of things a little bit rather than one thing a lot of bit. And it's really a challenge to figure out how to make that evaluation. Because everyone who reads that is used to the old way. We have one target and do one thing. And so I see a lot. I'm very excited to see how all of this unfolds. You know, you've got these things called hallmarks of aging. These are specific pathways that people have intervened on in cellular and animal models to extend life and health span. I think there will be I foresee a day when we'll have approaches to target those hallmarks and be able to help people for the problem that they have. So, for example, one problem that seems to be is accumulation of senescent cells, which are also pro-inflammatory and lead, at least in the animal models, lead to a lot of dysfunction. If you can knock them down to the animals do much better. So who should we test that in? What human should we test that in?
Yeah.
Who do we know has a high senescent burden and who doesn't? Who would benefit from a mitochondrial approach versus a not mitochondrial approach? So those are the kinds of things I've been thinking about. And I think probably, in my estimation, the field we're in is about where atherosclerosis research was in about 1962, which was 15 years before the first statin was tested, something like maybe more than that, 20 years before.
Yeah. Yeah.
We've got ways to go, but I think the payoff is potentially well worth it. Well worth it.
Oh, absolutely. No, it's exciting times ahead, that's for sure. And I agree with you, discovering this one way where we can measure all of these as a systems way, that would be really fantastic, in one way that can be recognized by everyone, right? So yeah, it's exciting. So before we wrap up, we'd like to ask our guests one forward-looking question. Across decades of working in aging research,
Right.
spanning epidemiology, clinical trials, metabolism, physical function, you work alongside some very incredible individuals, and I guess a lot of very, very smart people and influential thinkers. So if there is one person or maybe two that you think it will be particular important questions to answer about aging today, someone pushing the field in a meaningful direction, who would you recommend we invite to the podcast? podcast
Oh,
next, and why?
We
okay.
really put you on the spot, didn't we?
Okay. Uh, I don't see if I don't mention someone to get mad at me. See,
You can give us a whole list. I'm kidding. I'm kidding.
okay. Well, I mean, I think a person who seems to have a both a very detailed knowledge and very comprehensive and forward-thinking knowledge of aging, and I think most people that I know would agree with this, is Luigi Ferrucci, who's a NIA intramural scientific director of the NIA. Command of everything from cellular experiments to uh, very challenging human measurements to epidemiology is really exceptional.
Yeah.
So I definitely would pick him. So there are a number of people out there who have really interesting views about the future of aging research. I work with Jim Kirkland, and he will go, you press his play button and he'll go for a while telling you about things that could come to pass. And he's really stimulating to listen to him talk about those things. Work a lot over the years with Nir Barzilai, who also has a vision of where everything could go. And so it's all reasoned and well reasoned in both cases, and quite challenging. I wouldn't, time will tell if their vision pans out, but they have a lot of good stuff. Work with Nathan Labrasser is doing a lot of really good stuff as well right now, and I'm sure I'm leaving out a lot of people. Those would be, who would be intriguing, who you probably wouldn't ever think of, is Eileen Crimmins. Yeah. Eileen Crimmins is a demographer.
Yeah.
And is trying to evaluate a lot of the inspiration for the potential of lifespan and sort of the facts of aging that motivated this drive to the formation of geroscience. Actually come out of, or this marriage of biology of aging and demography came together to form geroscience. She's just a fascinating person to talk to about these sorts of things. So.
Yeah. Eileen is amazing. I've worked very closely with her, especially with the health and retirement study. It was one of the core studies that I used in my PhD.
And that stuff amazing. Is in there because of her.
Yeah, exactly. Yeah, she's an amazing resource and mentor. Cannot vouch enough for her. She's amazing. Yeah. Those are some amazing people. We'll definitely reach out to them.
I guess Stan Belsky's got to be on the list too. He's sort of.
Yeah, I actually reached out to Dan and said he should be on the podcast. So he's probably coming on very soon. So
he's also done some. When I saw his first papers, I was mad at him because it's stuff that I felt like I should have come up with. And I was mad.
He is very smart.
He's also extremely articulate, very good explainer.
He's very good. Well, we really appreciate you, Steve, coming on to the podcast and sort of talking about the science you have been doing for the past decades, I would say. And sort of it's amazing to have an expert like you be here and talk about sort of longevity and functional resilience. So thank you so much for joining us. And
it was a pleasure, and I hope a lot of people listen to your podcast, because this is obviously a very important. It's a very important topic.
Yeah,
and it's important both because it is just inherently interesting and important. It's important because there's a lot of misinformation out there too. And there needs to be some antidote to all the junk that people find easily accessible. Which is going to lead a lot of people to do things that really aren't going to help them, but may impoverish them.
Yeah, absolutely. No, I absolutely agree. And for that very reason, to our listeners, we will link Steve's work in our show notes so that you can read more about the amazing work that Steve is doing and potentially even follow up with him if you have questions. Don't email him with a lot of emails, though, just maybe a few. If you enjoyed this episode, don't forget to follow, share, and leave us a review. See you next time on Decoding Longevity. Thank you so much.
Thank you so much.
Thank
Right.
you.